Today is a review on applying systems of equations to real-world problems. So we'll have two problems that involve distance, rate, and time, one that involves a mixture problem. So let's take a look at the distance, rate, and time problems. First of all, they talk about a tailwind. So it says, with a tailwind, an airplane flies 900 miles in 2¼ hours. And so right away, we can start off writing an equation. Remember, we're having our distance equals rate multiplied by time, but the first sentence pretty much gives it everything we need. It talks about a wind, and we are going with the wind. And so when we go with a wind, that means we are adding wind speed to the rate of the plane. That's why we go faster, and we'll see that the time is smaller when we're going with the wind rather than against the wind. So we know the distance. It says it's 900 miles. So we can put that in place of the distance. Now, the time we know is 2¼ Now, I'm going to change this. I like to deal with fractions rather than decimals. So I'm going to change that to 2¼ which I will go ahead and now change to 9/4. And so all I did is just change it to that improper fraction form because I'll be able to reduce the fraction in a little while. So oftentimes using the fraction form makes the problem go a little faster. Well, the rate, let's get down to that rate. Remember, we've got two components of the rate. We've got the speed of the plane, which they want to know. So they want to know that plane's speed, which we will call R, and they want to know the wind speed, which we'll call W. So it's going to be R plus W because we're going with a tailwind. So always with the wind makes you go faster, so that's why we're adding that speed to the rate of the plane. Well, the next sentence, let's take a look at that one. That one we have a return trip. Return trip means we're going the same distance. So whenever you see that word, they're not going to tell you what that distance is. You just have to know it's the same. So we're going to go ahead and put that in there. 900 miles. And it's against the wind. Now, really, they probably should have said against the same wind, so we know the wind's the same, but we'll take it that way. And so we know that it's against the wind. So that tells us that the wind is working against us. That same wind W now is going to be minus W. And so right away I even know that part. I know it's going to be R minus W. And it says it takes 3 hours. So you can see it always takes longer when we're going against the wind because it's harder. The wind's working against us rather than with us. So we'll put that 3 in there. So now we're ready to solve. So when I solve this, I look at this, instead of multiplying by 9/4, look at the equations. Let's get rid of that 9/4. We can do that by multiplying by the reciprocal. So you can see why I changed that 2¼ to the fraction form, because I multiply by the reciprocal, and now I don't have that fraction anymore. That's a lot easier. And do the same thing over here, 4/9. And then treat this as 900 over 1 and reduce. 9 goes into 900. 100 times. So I multiply, and we see what we get. And so we'll go ahead and rewrite that top equation there. It's going to be 400. 400 goes 4 times 100 is 400, equals R plus W. Well, down here, we're going to do the same sort of thing. So let's go ahead and multiply by the reciprocal. Let's take this fraction or this 3 here and multiply by 1/3. That'll cancel out the 3 there. Do the same thing here, and I see that 3 goes into 900 300 times. So there's our new number. And so we can rewrite that. 1 times 300 is 300 equals R minus W. And you see how easy the equation is to solve now? All you have to do is add those numbers together. And when you do that, we end up with a 700 equals 2R. Make sure you add these R's up. 1R and 1R make 2R. The W's cancel out. It's the whole reason why we did this, is to be able to cancel out one of those unknowns. So we go ahead and solve from this point. Divide by 2, and we'll have our answer. So we have 350. 350 equals R. Well, what's 350? What's R? Well, let's see here. It is miles per hour. So we'll go ahead and rewrite that down there with the correct units. 350 miles per hour is the plane's speed. Well, we still need to find the wind speed. It's easiest just to substitute into one of these modified equations. So let's go ahead and take it and put it maybe in for this r right here. So we'd rewrite it as 400 equals, instead of r, we're going to write 350 and then plus w. And so from that point, all we have to do is that one step. Subtract that 350 from both sides, and we'll have our answer. So there it is. We've got 50 is the speed of the wind. Remember, you got to borrow. Change that to a 3. 10 minus 5 is 5. So 50 miles per hour, speed of the wind. So you'll see two problems like that, and we've got one mixture problem. So let's take a look at that. So remember, mixture problems, I always set up a little chart. Remember, I see it's dealing with percents, so it goes this way. We've got part 1, and remember, on your parts, you're always going to have a low percentage and a high percentage. And I'll write down part number 2 as the one with the high percentage. And so from there, we've also got a mixture. This is the total. So these two add together to make the mixture. Well, that goes across. Let's see what is the headings for the columns. Remember, you have an amount of volume. And so the amount of volume depends on the units. Let's see what the units are. They are milliliters. So I'll put ml for milliliters. And we're multiplying by a rate. And the rate in this case is a percent. So it's a percent of saline solution. So saline. And when we go ahead and multiply that, we end up with our amount of salt. That's what a saline solution is. Salt solution. And this is, I don't change the percent to the decimal form, so it's really amount of salt times by 100. And we don't really have to worry about that. That doesn't really affect the problem. It's just at the end of the answer, when we get our answer, it's the same answer. We don't have to change anything. We don't have to divide by 100 or multiply by 100. It's just that when you read these numbers off, these aren't actual amounts of salt. They're amounts of salt times by 100. So let's go ahead and fill in our chart. Start with that part number 1, the low percentage. A chemist mix a 20% saline solution and a 40% saline solution. No, they mix. They're mixing this stuff. So I know these are the parts. So one's a low percentage, so 20%. One's a high percentage, 40%. To get, whenever they say to get, to make, to obtain, this tells us that now we're going to be talking about the mix. So the mix has 60% or 60 milliliters. So 60 milliliters goes in the amount of volume, and it's of a 25% saline solution. So when you do these problems, you're always going to have a low percentage, a high percentage, and then the mix is going to be in between the two percentages. So they're asking how many of each do we need. So we don't know. They don't ask for a specific one. They want both. So we call one of them x. The other is an expression. Remember, they've given us the total, so it's going to be the total minus x. And then you just multiply across. So you multiply these. X times 20 is 20x. We have these two numbers. We multiply. Make sure you use that distributive property when you multiply this. So it makes 2400. And then a minus 40x. And then over here, we multiply 6 times 25 makes 150, and then just bring down that 0. Remember, these two get added together, and they equal this total. So one neat trick that we can do right now is collect these terms. So these terms right here are going to be added together, and that makes a negative 20x there. So when we write our problem, it's going to be negative 20x plus the 2400 equals the 1500. So remember, this 20x plus 2400 minus 40x, well, the 20x minus 40x made the negative 20x. So that's where I got that number. And so from there, just move some terms around. Subtract that 2400. Remember, when you do that subtraction, make sure you put the bigger number on top when you actually do it. And that way, you'll see that you end up having to borrow, and this becomes a 1, so it becomes 900 when we do that work. So negative 900 equals, and then negative 20x. And so from there, we end up having to divide, And we'll divide by that negative 20 on both sides. And what we can do right away is when we see the negative signs, they should cancel. Zeros here cancel, so it's just 2 into 90. And so when we do that work, we get 45. So 45 milliliters of the 20% solution. Now, how do I know it's the 20%? Well, that's what I do when I go back in here. So this is why we use this chart and label what we have for x. See, x, this is 45 milliliters right here. And I know it's milliliters because that was the volume, but if you look straight across, it's the 20% solution. So you need to specify that, 45 milliliters of 20%. And then go back into this part right here, 60 minus x. So put the 45 here. Subtract it from 60. That gives you 15. So 15 milliliters of the 40% right there. We have it in the chart. It tells us what it represents. So 15 milliliters of the 40%. So there it is, a mixture problem and a distance, rate, and time one.